Hello students, good evening. Today we will discuss about set theory. This is the fundamental part of mathematics and introduced by great German mathematician George Cantor. What is set theory? See, from the conception of set, the word set gives you what conception? Means collection of elements. Now, collection of what kind of elements? Collection of defined elements. Defined elements means, say, collection of 1, 2, 3, 4, up to 100 terms. That means this is called collection of natural number. Then 0, 1, 2, 3, 4, up to 100. So this is whole number. So in this way, collection of defined element is called set theory. Set. See, collection of defined elements is called set, or set is well-defined collection of elements. Now, in so many ways I can express. Say like A. N means set of natural number. W, set of whole number. See, set of natural number means it starts with 1 and goes to infinity. Whole number means it has one element extra, that is 0. Now, Q, set of rational number. You know, you are quite familiar with the term rational number. Means the numbers which can be expressed by P by Q form. Then Z, set of integers. Z plus set of positive integers. In this way, we can denote different types of sets. Say R. R means set of real numbers. And R plus means positive real. Set of positive real. Set of positive real. And script C, set of complex number. So this is the way I can denote different types of sets. So this much we have come to know that set is well-defined collection of elements. Now how can I frame a set? Let's discuss. I'm rubbing this part. Usually set is usually denoted by capital letters. But say A, B, C, D, etc. So set is generally denoted by capital letters. Now, suppose there is, see, set will start with second bracket. Suppose a set A contains 4 elements. It ends with second bracket. Okay, it starts with second bracket, ends with second bracket. Now, elements will be differed by commas. So this forming of set is called roster form or tabular form, where elements are taken in a taken and clubbed together and differed by commas. But see, if you get so many elements, infinite number of elements, and if you keep on writing in this way, it will nothing but time consuming. Then your purpose will not be filled. So another form came in later, say instead of writing these 4 elements, you can write natural number, because natural number starts with 1. What kind of natural number? Which lies between 1 to 4. So this type of formation of set is called set builder form. Set builder form. What is the privilege we are getting from set builder form? If you are told to write 100 elements even, suppose 100 elements, say you are told to write 100 elements, and if you write in this way, the way you have written in tabular form or roster form, it will just encroach time. So you better write n, where n lies between 1 to infinity, or if it is 100, confined in 100, 1 to 100. So a set contains first 100 natural number. So instead of writing all numbers 1 to 100, you can write natural number and give the interval where this natural number lies. So this is called set builder form. Here you see 1 is an element belongs to A. So 1 is an element belongs to A. In what I have written, so how can you write it mathematically? You can write 1 belongs to A. See, this sign is actually, this sign represents belongs to. Okay? Now, suppose if this set contains 4 elements, 1, 2, 3, 4, does 5 belong to this? No. Then I can write 5 does not belong to A. How to write mathematically? Write belong sign, scratch it. So 5 does not belong to A. You can represent in this way. 5 does not belong to A. So mathematically I can write 5 does not belong to A in this manner. Hope you understood. I'm rubbing this part. Just go through once. Now, suppose there is a set A. Suppose a set does not contain any element. Then what kind of set is this? Then the set is called null set. Then the set is called null set. This null set will be denoted by this null set will be denoted by 5. You can ask me that null set doesn't contain no elements. It contains no element means if I insert 0, will it remain as null set? No, because once you insert 0 in the set, that means it will be considered as one of the elements. So it will not remain as null set. Now, number of elements in a set. Suppose a set contains 3 elements. How many elements are there? 3. So I will denote it, the number of elements of the set, by n of a, 3. This is called cardinal number. Cardinal number is nothing but number of elements in a set. Now, what is the cardinal number of null set? Then you can write 0. Okay, if you put 0 element, or if you put or insert 0 element in a set, then that will be considered as an element. So it will not remain as a null set. But once you find the number of elements in null set, then 0. So number of elements or cardinal number of null set is 0. Okay. So we have come to know what is null set and what is cardinal number. Okay. So I am going to rub it. Hope you understood. Go through once. Let us take one set, say one contains 3 elements, 1, 2, 3, and B is another set, 3, 4, and 5. And let us combine these two. Let us combine these two. Then combination of two sets is called union. Combination of two sets is called union. Okay. One example. Suppose in a room 3 students are sitting of engineering stream, and another room 3 students are sitting of medical stream. Now, when total students are told to count, then apparently it seems to us 1, 2, 3, 4, 5, 6. But see, after counting, what did you see? That one element comes twice. Means, for example, one student can sit for engineering and medical both. So here one student is playing the role of 2 students. So that student will not be considered as 2 students. Okay, his or her name is enlisted in both the room. But when you are counting in straight approach, then it will be seen to us 6. But here, after when we call the students by their roll number, then one student will come twice. So then one has to be a student. See, unions, U will be considered, U will be taken to imply the union of 2 sets, A union B. Apparently, it seems to us 6 elements. See, 1, 2, 3, 4, 5. So how can this 3 comes twice? How can this 3 come twice? So 1, 3 has to be excluded. 1, 3 has to be excluded. Now, this matter, let us represent by diagram. See, let us take one two round shaped ball partially overlapping with each other. See, A and B. This is called Venn diagram. Venn diagram. When the sets are being represented by diagram, this type of using round shaped ball, then this diagram is called Venn diagram. Now you see, suppose this element, this row, which is represented by a round shaped ball, round shaped figure 1, 2, and 3, and this B is represented by another round shaped figure 3, 4, 5. So one thing is found common, that is 3. So if you count 3 twice, That means one student or person or element will come extra, and that has to be a student. So that common region is called intersection of A and B. How to denote it? Denoted by A intersection B. So this part is nothing but A intersection B. What about this part? This is the flat counting of two sets, means addition, means A plus B. So actually we have got a relation that A union B. If you are asked to find A union B, then your approach will be flatly added the total number of elements and then count the common elements and exclude. Then you will get A union B, A plus B minus A intersection. This is a good conception. See, if you add this part, this to say, this common part will come twice. So one to balance, one part has to be excluded. Now, by cardinal number, I can express it. Number of elements in A union B is equal to number of elements in A plus number of elements in B minus number of elements in A intersection. Okay? A union B, NA plus NB minus N A intersection B. This is one important property which will rule probability even in later. In class 12's last phase, you will have to face probability, and in that time, in establishing the basic rule of probability, this property of set theory will play a key role. Even in class 11 last phase, you will get probability theorem which is strongly related to this formula. So A union B is equal to NA plus NB minus N A intersection. Okay? Hope you understood what is union and what is intersection. Now we must be more specific on union and intersection, because if you don't get union and intersection, then the conception of see permutation, combination, combinatorics, probability will not be built up. So we must be more specific. Let's see how to be specific more in understanding union and intersection. I'm running this part. Hope you understood. Suppose A is a set contains 1, 2, 3. B is a set contains 3 elements 3, 4, 5. 1, 2, 3, 3, 4, 5. Now, if you are told to find the union, then that will give you 1, 2, 3, 4, 5, and intersection, then that will be only 3 because 3 is the common part. Now, if this part is not provided, only this part is provided. A union B is given, A intersection B is given. See, if I consider A intersection B 3, means A intersection B is itself a set which contains the element 3. In that case, what conclusion I can draw? That 3 belongs to both A and B. 3 belongs to both A and B. 3 belongs to both A and B. That means intersection means this means intersection. Intersection means both conditions. Both will get the job. Both will be excluded from the team. So in that case, intersection concept will come. But see, if you are provided by this set A union B, which contains 5 elements. Now, seeing this element, can you see that which element belongs to which set? And can you say that one belongs to A or 2 belongs to B? Then we can't say, because then the A and B sets are removed, and we are asked to find that the elements belongs to which particular set. We can't say saying that, but this much you can say that 1 belongs to either A or B, 2 belongs to either A or B, 3 belongs to either A or B, 4 belongs to either A or B, 5 belongs to either A or B. That means union. Union means or condition. Union means or condition. For example, say X belongs to A intersection B. What does it mean? X belongs to both A and B, and X belongs to A union B. Union means just we are not or. How can I write inverse? X belongs to either A or B. Either A or B. So, hope you understood that intersection means and, union means or. Okay? So, there is no confusion, I think, in comprehending union and intersection. Students generally get confusion over here, but see, if you analyze this example and go through the language of this type, then easily you can comprehend the concept of union and intersection. Okay, I'm rubbing and skipping to the next part. Next topic is, suppose A set contains 3 elements and B set contains 4 elements. That means all elements of set A are the elements of B, but not the reverse. Then set A is called subset of B. A is the subset of B. Okay, all elements of A are the elements of B, but not the reverse. Then A is called the subset of B. This is the notation of subset. So, but there is one question. How this equality sign comes? That means, is there any possibility of 2 sets equal? What is called equal set? Then that question will come. If the elements of set A and elements of set B are same, then we can say equal set. But here, no question of equality. Then I can remove this equality sign. Then it is called proper subset. Proper subset. A is proper subset of B. A is proper subset of B. But you see, in natural number, it starts from 1, 2, 3 up to infinity. And whole number 0, 1, 2 up to infinity. So all numbers of n are also the number of w except 0. So A is the subset of w, but there is one case for which n and w may be equal if 0 is excluded from w. If you remove 0, then also this is the set of whole number. In that case, there is the possibility of equality of n and w. So this is called subset. Here n is subset of W. Okay, N is subset of W, and W is superset of N. W is superset of N. Hope you understood. So, if A is called proper subset of B, then we can denote A by the symbol of proper subset of what? B, because there is no equality sign. But if there is a possibility of equality of two sets, then subset N is called subset of W, or W is called superset of N. Hope you understood. So, what conclusion I can draw? In other way, also you can say that A is subset of B if every element of A is also element of B. Or we can say A is the subset of B if A belongs to A implies A belongs to B. A belongs to A implies A belongs to B, then A is the subset of B. And B is the superset of A. So I hope this much you understood. So, another example, say phi. Phi means null set. This phi is subset of all set. Phi is subset of all set because phi doesn't contain any element and n phi is 0. So as no element belongs to phi, so phi is the subset of all set. Hope you understood. I'm wrapping this part. Now, universal set. Universal set. It is the superset of. It is the superset of all sets. It is called basic set. Basic set. See, in this, if you analyze the nomenclature, you can understand the meaning of universal set. It is the superset of all sets, or all sets are subset of, or all sets are subsets of, all sets are subsets of universal set, denoted by script U or S. Now, suppose if you consider any state, say West Bengal or Assam or Punjab, see, these states are subset of India, and India is superset of these states. Means with respect to the states, India as a nation will be considered as universal set. Okay. So universal set contains all sets. Okay. It is the superset of all sets. It's denoted by script U or S. Now, universal set is the superset of all sets we have come to know. Now, let us draw one figure. Say this is universal set. Universal set. and there is an element X and there is a set A. Now the figure depicts what? What does it depict? Does this X belong to A? This figure suggests what? No. X does not belong to A, and you are quite familiar with the term not belongs to. X does not belong to A. Where does it belong then? In the remaining part. In the remaining part. Then X belongs to the set of the region of universal set excluding that particular set. So this part is called complement of set A. That is called complement of set A. Complement of set A means you can write A superscript C. A superscript C. So A superscript C means, or I can say X belongs to A complement means X belongs to union excluding A. Means that universal set excluding A. So one element does not belong to a particular set means it belongs to the remaining part of the universal set excluding that particular set. Or X does not belong to A complement means X belongs to where? A. Or reverse, if X does not belongs to A means X does not belongs to A means it belongs to A complement. Okay, we can comprehend this concept by considering a simple example. Okay, let us take one example. I'm wrapping this part. Let us take one example. Say one universal set is defined by natural number which starts from 1, ends with 10. Or I can write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All of you know this is set builder form, this is roster form. Now A is a set, contains 2 elements, 1, 2. What is A complement? A complement means that part of universal set which exclude the set A. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, excluding 1, 2. So the remaining part means 3, 4, 5, 6, 7, 8, 9, 10. So this is the A complement with respect to A if we consider this set as universal set. This is universal set. Okay, understood what is a set and its complement? Now you tell me, if I get A intersection A complement, see A contains 1 and 2 and A complement contains 3, 4, 5, 6, 7, 8, 9, 10. So do they have any common part? No. So their common part is null set. So null set. No common part, null set. So what is the cardinal number of this part? Means how many elements are there in the common region of A and A complement? 0. There is 0 number of elements between A and A complement. So if I consider, see this is a set A, and if I consider this region as universal set, then the remaining part you will be considered as A complement. Okay, This will be considered as a complement. So hope you understood a set and its complement. And you see, for your example again, one example again I'm showing you. See, 1 belongs to A, but that 1 does not belong to A complement. So 1 does not belong to A complement. Or you see, 3 belongs to A complement, which means 3 does not belongs to. Understood? So this is a simple example to comprehend the set and its complement. Hope you understood. So I'm going to skip to the next part. Let us take two sets, A and B. A and B. And this part you have come to know, A intersection B. And this part, this region, it is A union B. This is the diagramical, it is the representation by diagram that is called Venn diagram, which you were taught earlier. Okay, hope you understood. In case of three sets, if three sets are partially overlapping each other, this is A, this is B, this is C, three sets. See, this is the region which represents A intersection B. This is the region represents B intersection C. See the common part B intersection C, and this is the area represents A intersection C. So if you want to combine them, means by union, in A union B union C, that means with flat approach, or in general approach, you need to add these three sets, A plus B plus C. But what problem in adding two sets we had? We got A union B, A plus B, but here this common part came twice, so one had to be subtracted. Here also you see, if you add A, B, C, first this common part, common to both A and B are coming one time extra, so subtract A intersection. This common part is coming twice, one has to be subtracted, and this common part is coming twice, one has to be subtracted. But if you are pursuing the subtracting of this common part, like in this manner, this part, already the common region of these three common parts already subtracted once, and when you are going to subtract this part, this region is being subtracted twice. So if you subtract each common region of two sets, A, B, B, C, and CA, then the common region of three sets subtracted twice, and so you have to add once. So A plus B plus C minus A intersection B, B intersection C, C intersection A, and this part will be added because it was excluded twice. So by cardinal number I can write A union B union C, NA plus NB plus NC minus A intersection B, B intersection C, C intersection A plus N, A intersection B intersection C. So this the property of this involves two sets and three sets is represented by Venn diagram and formula. Hope you understood. So I'm rubbing this part. I'm going to skip to the next part. Now, if this set A and this set B are kept aside, means they don't have any common part. So I will write A intersection B null set. Okay. Then how can you define set A and B? If you get this type of set, then A and B will be called disjoint sets. Disjoint sets. Okay, disjoint sets. So by definition, therefore, A and A complement must be disjoint to each other as A intersection A complement is null. Okay, A intersection A complement is null. And obviously, we have taught earlier because they do not have any element between them. Okay, so a set and its complement are disjoint to each other. Okay, so this is the condition of disjoincy of two sets. Hope you understood. I'm going to skip to the next part again. Suppose a set contains two elements. Now, how many subsets does it have? Obviously, see, you can get a set, say 1. What kind of set is this? It which contains only one element? The set contains only one element is called singleton set. It contains only one element. Okay, like contains no element, null set or empty set, and only one element singleton set. So one, how many subsets it has? One. Obviously, you have to this one has to be confined in two brackets. It can be 2, it can be 1. Is that all? Is that all? No, because earlier by definition we have come to know one thing, that null set is the subset of all sets. So this number of subsets A has. So A has 4 subsets. A has the set A has, therefore set A has 4 subsets. Now set A has 4 subsets, so collection of 4 subsets is called power set of A, denoted by P. Okay, denoted by P. So number of subsets of a set A is called power set. Okay, therefore number of subsets of a set A is called power set of A. Is called power set of A. Now, like here you got a simple example, only 2 elements. Now, if A has m number of elements, if A has n number of elements, then what is the power set? See, number of subsets of a set is called power set of A. Here we got power set is 4 because 4 subsets we are getting. So how can I write? But we had only 2 elements in a set A, so I can write 2 square. Now, if A has n number of elements, then number of subsets, n number of elements in set A, then number of subsets of A, that is power set of A is 2 to the power n. That is the formula. Once you get that A has 2 elements, then power set A 2 square, m elements 2 to the power n. So this is the definition of power set. Hope you understood. Now instead of now easily you can say, if a set contains 3 elements, then power set 2 to the power 3 means 2 cube 8. And if you are told to find those subsets, see, singleton set, it contains 3 singleton sets. It contains 2 elements at a time. It will choose 2 elements at a time. 1 2 2 3 1 2 2 3 3 1, and that set which contains all 3 elements. But that is not all, because you know that null set or empty set is the subset of all set. So these 8 subsets you will get, and that will be considered that as power set of A. Understand? That will be considered as power set of A. Earlier we got that collection of 4 subsets is called power set. So collection means it must be confined in a bracket, obviously. So you must confine in second bracket. This is the power set. Hope you understood. I am going to skip to the next part. Now, few properties based on union and intersection. Few properties based on union and intersection. See, one property we were taught already, A intersection A complement null. See, we have gone through a figure. This is A, this is universal set, and this part is A complement. So A and A complement do not have any common region. And if I unite A and A complement, A union A complement, then I will get universal set. Okay? See, if you bring null set with the operation union with A, so it will induct nothing, because null set contains no element. So it will remain A. And A intersection null set. Okay? So A has the subset null, and A is the superset of null. So what is the common part between A and null set? Null, empty set only. Okay. Now, suppose universal set union A. Universal set and union A. So it will give you universal set only. And universal set intersection A, common part is A. So few those basic conceptual properties on union and intersection you have to learn. Then we will go through associative property. Associative property. Associative property. What is that? A union B union C is equal to A union B union C. See, this associative property you are taught even in number system in your junior classes. But here, to establish this result, the method will be a little bit different. Okay? See how we can establish. I am letting one element I am letting one element X belongs to A union B union C. And in the first phase of this, class, we got union means it represents those cases which involves or condition, A or B. Okay. So A union B means A union this thing means I can write X belongs to A or X belongs to B union C. Okay, because union means or already we are taught. Therefore, X belongs to A, or you put this thing in bracket, that union also to be splitted with or concept. X belongs to B or X belongs to C. Hope you understood. Now you just skip this bracket one step left. How? X belongs to A or this means X belongs to A or B, or X belongs to A or C means this will be clubbed with this with or sign. This will be clubbed with this again by or sign with the concept of or. See, X belongs to A or X belongs to B, or X belongs to A or X belongs to C. Hope you understood. That will give you what? That will give you X belongs to A union B or X belongs to A union C. But still that or will play the role. X belongs to A union B union A union C. So what does it mean? I started with left hand side and am able to show the element which belongs to left, the set of left hand side also belongs to set of right hand side. So what does it depict? Earlier we got A belongs to A. It implies A belongs to B. Then A is the subset of B. That concept you got earlier. So here also that concept will recur. X belongs to this implies, you see, you put this implies sign in each case. X belongs to this implies X belongs to this. Therefore A union B union C is the subset of A union B union A union C. This is result 1 I am denoting. What about result 2? See, from left hand side we can reach the right hand side. Now we can prove it in reverse manner. Another element I am choosing that belongs to this set. Let Y belongs to A union B union C. Again, same concept. This union means or. So Y belongs to A union B or Y belongs to C. That basic concept belongs to what is meant by or. Now this union also to be splitted. Okay, Y belongs to A or Y belongs to B, whole bracket, or Y belongs to C. Now like the previous procedure, you skip this bracket one step to its right. Why? Because this Y belongs to C are related to A or B with or sign. X belongs to A or Y belongs to C, or Y belongs to B, or sorry, just wait. there is one mistake in the proof, I think. The one mistake I have done, sorry. I'm rubbing this part. Please rectify. Please rectify. The X belongs to A or X belongs to B or X belongs to C. So, okay, up to this stage, we could proceed. That was right. Now you just, I told it, but by a flicker of moment, I did a mistake. And it actually, why did I do the mistake? Because this mistake actually happened with the students. Just to show you, I should skip this bracket one place. 2 is left. See, X belongs to A or X belongs to B will be confined in a bracket, or X belongs to C. Now these A and B will be related or connected with or, means X belongs to A union B or X belongs to C. Again, instead of this or, you write X belongs to A union B union C. So what does it mean? That X belongs to this implies X belongs to this. So this set is the subset of this according to this definition of subset. Okay, so A union B union C is the subset of A union B union C. This is result 1. Now I will start with right hand side. I am letting one element Y, let Y belongs to A union B union C. What does it mean? Instead of first, I will write or sign instead of this union. A union B or Y belongs to C. Now this union will be broken into 2 parts using or. Y belongs to A or Y belongs to B or Y belongs to C. Now, like the previous procedure, skip this bracket. Skip 2 is right. Y belongs to A or Y belongs to B or Y belongs to C. Now Y belongs to A or Y belongs to or means union. Or means union. So again, instead of this or, I will write union. So what conclusion I can draw? What conclusion? That this part also the subset of this. Okay, therefore A union B union C is the subset of A union B union C. I am labeling this by 2. Result 2. Now I will combine 1 and 2, joining 1 and 2. See, this is the subset of this, and left hand side is the subset of right hand side, and right hand side is the subset of left hand side. Combinedly, they are equal set. Okay, like A less than B and B less than A combinedly gives you what? A equal to B. So joining 1 and 2, we get A union B, A union B union C, A union B union C. Okay, thus the result is established. This is called associative property. So at home you can prove its reverse order. How? Means it is related to union. Now in the same manner we can prove the intersection part. Okay, I hope easily you can do using this concept. Okay, hope you understood. So let us skip to the next topic. I'm rubbing this part. Another property, you see A union B intersection C. A union B intersection A union C. Okay? And A intersection B union C. A intersection B union A intersection C. So I will try to establish the first one in the same manner. You can establish the second one. Okay? And this is called distributive property. Distributive property. Like the previous process, I will pursue the same way, with the same way to establish this result. Say, let X belongs to the set of left hand side, A union B intersection C. So that implies what? Union means or. X belongs to B intersection C. That implies what? X belongs to B and X belongs to C. Now you see that X belongs to A. Where the distribution is being done, X belongs to A are related to B by OR sign. X belongs to A or X belongs to B. Put them in a bracket. And same X belongs to B have relation with C by this OR sign. X belongs to A or X belongs to C. And there is operation AND between them. Now, instead of OR, I can write X belongs to A union B and X belongs to A union C. Why? Because OR means union and AND means intersection. A union B and intersection A union C. So, what does it represent? That X belongs to this implies X belongs to this. So this is the subset of this. Therefore, A union B intersection C is the subset of A union B intersection A union C. This is result 1. Now, the same way I can come from right hand side to left hand side. Another element I am choosing. Let Y belongs to A union B intersection A union C. Now, this union means this is AND. Y belongs to A union B and Y belongs to A union C. Now this union means OR. Y belongs to A or Y belongs to B. C implies sign. And Y belongs to A or Y belongs to C. So from this, what conclusion I can draw? That in these two, Y belongs to A is the common part. Y belongs to A are related to both B and C. C intersection is given. Y belongs to A. Y belongs to A or Y belongs to B and Y belongs to C. Now AND means intersection. B intersection C. Now OR means union. A union B intersection C. So, like the previous procedure, we can say as Y belongs to this implies Y belongs to this. So this is the subset of this. Therefore, A union B intersection A union C is the subset of A union B intersection C. This is result 2. Now joining in 1 and 2, joining 1 and 2, we get A union B intersection C is equal to A union B intersection A union C. And in the same manner, you can do the second part. Okay, that's your job. You can do by your own IQ level and intellect. So I'm going to skip to the next part. Now, Demorgan's law. Demorgan's law. What is that? A union B whole complement. A complement intersection B complement. And A intersection B whole complement. A complement union B complement. So I'm going to show you the procedure to establish this relation by your own. Easily you can establish this relation, or if you wish you can use Venn diagram. Now if I want to establish this part, I am letting like previous procedure, you are quite familiar. A union B whole complement. What does it mean? You are taught X belongs to A complement means X does not belong to A. So I can write X does not belongs to A union B. So by the definition of union, we should write or. But you see, if I take the help of Venn diagram, what is A union B? Now this region, this shaded region is A union. So one element X does not belongs to A, does not belong to A union B means it does not belong to both A and B. So unions, definition, by definition we can say this represents OR. But if I consider this Venn diagram, which is represented by this shaded region, and where X does not belong to the whole shaded region, then I can say X does not belong to A. Can't say it does not belong to A or B. Why? Because if it does not belong to A, then it can belong to B, or if it does not belong to B, it can belong to A, but it is not belong to the whole region. So though A and B are related by union, but by conception we can say X does not belongs to A and A does not belongs to. Okay, hope you understood. That means X belongs to A complement and X belongs to B complement. Now X belongs to A complement intersection B complement. So using the previous concept, I can write this is the subset of this. Therefore again I can write this is the subset of this. This is the subset of this. This is result 1. Now start from right hand side. Let Y belongs to A complement intersection B complement. So by conception I can write, can you tell me by Venn diagram which part actually depicts A complement intersection B complement? See, which part actually A complement? If I draw the Venn diagram, this part is A. So the remaining part is A complement and this part is B. So remaining part is B complement. So X belongs to A complement and an intersection given. So what can I write? The intersection means X belongs to A complement and Y belongs to A complement, Y belongs to B complement. That means Y does not belongs to A and Y does not belong to B. So what does it mean? The element which is not belonging to both A and B means actually the reverse concept of this. It does not belongs to A and does not belong to B means it does not belong to the whole region A and B. Though it is an, but by conception I can write This is A union B. Okay? It does not belong to A union. So it belongs to A union B whole complement. So this is the result 2, and by 1 and 2, we get A union B whole complement. A complement intersection B complement. This is called Demorgan's law. So important laws are proved. Few things still left, and in short span we will discuss. I'm rubbing this part. Wait for a while. Now, difference of two sets. Suppose A is a set and B is a set are overlapping partially with each other, that they have a common region, and suppose X is an element belongs to A. That means it does not belongs to B. Means here X belongs to only A, not B. So that is called A minus B. Means difference between two sets. Means A minus A intersection B. That means A intersection B complement. So the difference between two sets can be denoted by, can be expressed by A minus B, A minus A intersection B, A intersection B complement. Suppose A is a set 1, 2, 3 and B is a set 3, 4. Then A minus B will be what? The element which belongs to A but not B. 1 and 2 belongs to A but not B, because 3 is an element which also belongs to B. So only this part is A minus B. So 1, 2. What is B minus A? See, if any element Y belongs to B, Y belongs to B, belongs to only B. What does it mean? B minus A means the part belongs to only B but not A. You can write B minus the common region intersection or B intersection A complement. So here B minus A is what? 3. Because 3 is the element, sorry, 4. 4 is the element. 4 is the element, belongs to B but not A. Now, symmetrical difference. Symmetrical difference between two sets A and B, that is A minus B delta B minus A, means combining these two sets, a new set will be formed. 1, 2 and 4. This is called symmetrical difference between two sets. So we are in the verge of conclusion of set theory. Only one topic is left, that is Cartesian product of two sets. Cartesian product. So let us rub it. I hope you understood the difference between two sets. Cartesian product of two sets. Cartesian product of two sets. See, if you get a set like this, 1, 2 and B 3, 4. Now Cartesian product means how many ordered pair you can form by the Cartesian product of A to B, like this. A to B, A cross B. It doesn't mean normal multiplication. See, 1 will be plugged with 3, This will form an ordered pair. Ordered pair means what? XY form. XY. See, Cartesian product A cross B. It will be in XY form where X belongs to A and Y belongs to B. From this concept, we can extend the concept of relation and then to function. This is the backbone of relation, function, calculus, everything. So A cross B, 1, 3, you see 1 belongs to A. So how many ordered pair it can form with the elements of B? 1, 3, 1, 4. And 2 belongs to A, 2, 3, 2, 4. 2, 3, 2, 4. So this is the Cartesian product between two sets A and B. That doesn't mean it is equal to B cross A. If it is B cross A, then see how many elements how many ordered pair that 3 will form with the elements of A. 3, 1, 3, 2, 4, 1, 4, 2. So you understood? And obviously in this case, A cross B not equal to B cross A. If it equal, then what happens? That will be discussed in the chapter function. Okay, so all topics of set theory, somehow in this short span I could touch. See, now based on this theoretical part, we have to extend our knowledge by solving the problems of your textbook, different textbook. And see, if you get good grip on set theory, you will get good grip on relation, function, then calculus. So this chapter, the basic mathematics, if you go through, then so many branches will be, so many avenues will be open for you. So I have tried to explain out of that demand in this video. Hope you understood. Then so see you again. Have a good day.